In this lecture, I am going to discuss about unit impulse function, or you can say unit impulse signal. In previous lecture, I have discussed how you can write the equation of a rectangular pulse in terms of unit step function. Let us consider xt is a rectangular pulse of width a and its height is 1 by a, or you can say the amplitude of this rectangular pulse or rectangular signal is 1 by a. Then in previous lecture I have discussed how you can write the equation or mathematical expression for this rectangular pulse in terms of unit step signal. This signal is starting at t equal to 0. So the first term will be ut minus 0, and this signal is terminated at t equal to a. So the second term will be t minus a, and the amplitude of this signal is 1 by a. So you have to multiply by its amplitude. In this way, you can get the mathematical expression of the rectangular pulse in terms of unit step signal. Now, the area of this signal will be its width into height, which is equal to 1. Now, what will happen when you will reduce the width of this rectangular pulse in such a way that its area remain constant, or in such a way that its area will not change. So by keeping area constant, when you will reduce its width, then obviously the height of the pulse will increase to keep area constant. So as you will reduce the width by keeping area constant, obviously its height will increase. Now the question is, what will happen when you will reduce its width to 0? Or what will happen when width of this rectangular pulse is tending toward 0? Then what will happen? The width of, if you will reduce its width to 0 by keeping area constant, obviously if you will reduce this term, then obviously the height 1 by a will increase to maintain area constant. And if a is tending towards 0, then obviously to keep area constant, the height will tend toward infinity. So you will get a rectangular pulse when width of this rectangular pulse will make equal to 0, or will become equal to 0. Then what will happen? You will get a rectangular pulse of 0 width. You will get a rectangular pulse of 0 width, but the amplitude of this rectangular pulse will tend toward infinity. So such type of rectangular pulse, or the rectangular pulse of 0 width and infinite amplitude, is called impulse. So this is called impulse. So impulse signal is basically a signal, or you can say impulse signal is basically a rectangular pulse of 0 width but infinite amplitude. The amplitude of the impulse signal will be infinity. And mathematically, you can express impulse signal as delta t will be equal to 0 everywhere, every or each value, any value of t, the amplitude of impulse signal will be 0. and at t equal to 0, its amplitude is not defined or undefined. Undefined. So this is the mathematical representation of impulse signal. You can say impulse signal is a signal, or you can say impulse signal is a rectangular pulse of zero width and infinite amplitude. Or you can say the signal which magnitude is zero everywhere for any value of t except at t equal to 0, and at t equal to 0 its amplitude is not defined because it is tending toward infinity. So such signal is called impulse signal. And what will be the area under this signal? As you are reducing the width of the rectangular pulse by keeping area equal to unity. So area under this rectangular pulse, or you can say uh, area under the rectangular pulse of width 0 and amplitude infinite will be equal to 1. So if you will integrate, or if you will calculate area uh, in between minus infinity to plus infinity delta t dt, if you will calculate area under the impulse signal, then you will get 1. So that is why the impulse signal is called unit impulse signal. That is why this signal is called unit impulse signal, because area included or area under unit impulse signal will be unity. That is why this is called unit impulse signal. But you must note that at t equal to 0, its amplitude cannot be defined. It is tending toward infinity. Here 1.0 is written, but this is for the area which is under this pulse and which is equal to 1.0. So you must remember 2 point. First, unit impulse signal is a signal which has zero magnitude, zero amplitude everywhere except at t equal to 0. At t equal to 0 it is not defined. First you have to remember this. And the second, the area under unit impulse signal, this integration, this is the area under unit impulse signal which will be equal to 1.0. So these two mathematical expression, these two are the mathematical expression for representing unit impulse signal. And the third point is, what will be the value of this expression? What will be the value of this mathematical expression? This mathematical expression represent the differential of any quantity with respect to time. As you have already studied in 11th or 12th class, this is first principle to obtain differential of any quantity or any function. So this expression is basically the differentiation of unit step function. So when a tends toward 0, then this xt will become equal to delta t. So third mathematical expression which you can note is impulse signal is simply a differentiation of unit step signal. So in this way, there are three ways through which you can represent unit impulse function. One, its amplitude will be 0 everywhere except at t equal to 0 where it is undefined. Or you can define impulse signal through by its area. Area of unit impulse signal will be always 1. And third, the unit impulse signal will be the differentiation of unit step signal. So in this way, with the use of unit step signal, you can get the impulse signal. So this is all about the impulse signal, or impulse signal is also called generalized function. Impulse function is also called generalized function. So this is all about the impulse signal. In the next lecture, I will discuss the property of impulse signal, because the knowledge of the property of impulse signal is very, very important to analyze various characteristics of other types of signal and to solve various mathematical expression in which impulse signal has been usually included. So that type of mathematical problem, or for the analysis of various signal, the property related to impulse signal is very important. So in the next lecture, I will discuss about the property of impulse signal.